we will discuss about IIR filter. IIR means infinite impulse response. One example is take h of n as half power n into u of n. U of n means it contains infinite number of impulses. If you expand it, it is like this: half power 0 means 1, half power 1, half square, half power 3, and so on. The impulse response contains infinite number of samples. Then IIR filter, finite number of samples, FIR filter, infinite number of samples, IIR filter. Here the input output relation IIR filter is like this: y of n plus a1 y of n minus 1 and so on up to an y of n minus n, which will be equal to b0 into x of n plus b1 x of n minus 1 . That is about input output relation. Here this output will depend on the previous output and input. Here this output will depend on input and previous output, IIR filter. I have already discussed about FIR filter. In FIR filter, the input output relation will be like this: y of n will be equal to h of 0 into x of n plus h of 1 into x of n minus 1 and so on. If you observe, it is depending on only input. FIR filter depends on only input, whereas IIR filter depends on previous output also, input and previous output, input and previous output. Here only input. That is the difference in the input output relation between FIR filter and IIR filter. Here h of z will be like this, that is the transfer function in FIR filter is in this manner. If you observe, there is no denominator, only numerator will be there. Okay. That is a transfer function of a FIR filter. Now I will identify transfer function of IIR filter. Apply Z transform, then it will be like this. H is always y by x. So finally, this is the transfer function of a IIR filter. If you observe, it contains both the numerator and denominator. Numerator is there, numerator is one polynomial and denominator is another polynomial. If only numerator is there, FIR, If numerator and denominator both are there, that will be IAR. Like this we can easily identify based on transfer function of a system. Now I will discuss about structures of IAR filter or realization of IAR filter. There are two structures. One is a direct form 1 structure, another one is direct form 2 structure. And this is the input output relation in a IR filter. Now take these terms to the right side. So y of n will be like this. Now we will see the implementation of this one using direct form 1 structure. So y of n depends on the input and the previous output. So take x of n, so here this is x of n, so x of n is multiplied with b0 into x of n. Then we need x of n minus 1, so take one delay element and it is multiplied with b1, and next term will be definitely b2 x of n minus 2. So take one more delay element and multiply with b2 and so on, like this. The last one will be bm. Now add all these signals. That is about the input side. It also depends on the output depends on previous output. So this is output y of n. Here I need y of n minus 1. So generate y of n minus 1. So pass it through a delay element. It is multiplied with minus a1, and I need y of n minus 2. So use one more delay element, multiply with minus 8 and so on. And add all these y terms. Finally, this y of n is sum of x terms and y terms. Just add these two. So that is a direct form 1 structure. First write x terms, then y terms. Here the number of delay elements will be, the number of delay elements in direct form 1 structure will be, here the last term in x is x of n minus m. That means we have to go up to m. That means m delay elements are needed for x, n delay elements are needed for y. So the number of delay elements will be m plus n. That is about delay elements in direct form 1 structure. And number of adders will be same as number of delay elements. So number of adders will be m plus n. Number of adders will be m plus n. And the number of multipliers will be, if you observe carefully, here m plus 1 x terms are there. b0 to bm is m plus 1 terms, and here a1 to an means n terms are there. That means the number of multipliers will be m plus n plus 1. Just add here a2 is a1 is multiplied with y, so one multiplier, a2 is multiplied with a second multiplier, like this. This is nth multiplier. Here m plus 1 terms are there, so m plus 1 multipliers here, because b0 is multiplied with x, b1 is multiplied with x of n minus 1, and so on. So the number of multipliers will be m plus n plus 1. And you may get one doubt about adders, why it is m plus n. See, if you observe carefully, here the total number of terms are m plus n plus 1 terms are there. So whenever we add, suppose take a plus b means one addition. Suppose a plus b plus c, if we add 3 numbers, that is 2 additions. If we add 2 numbers, that will be 1 addition is needed. To add 3 numbers, 2 additions are needed. Suppose if the number of terms are m plus n plus 1, then the number of additions definitely will be 1 less than that term. So m plus 1, m plus n additions, that is why m plus n additions, m plus n plus 1 multiplications, and delay elements are m plus n. That is the reason. That is about direct form 1 structure. Direct form 2 structure means just interchange these two. So according to control system theory, whenever two blocks in series can be interchanged according to block diagram algebra, we can interchange these two blocks. The reason is both will be equal to G1 into G2. Both are equal to G1 into G2. That is why we can always interchange blocks, two blocks, according to block diagram algebra. So this is one block and this is another block, so we can interchange. So that is a direct form 2 structure. If you interchange, that is a direct form 2 structure. So that means first write first write this block followed by this block. So first I wrote this one, then I will draw this one. So, first interchange these two blocks. Now, observe this diagram carefully. After interchanging, if you observe carefully, this signal is going like this and like this. Here that is, it is passed through one Z inverse block, here also Z inverse block. The same signal is going like this, like this. Here I am using two different Z inverses, but actually there is no need of two different Z inverses, because the same signal is going like this and like this. So, this value and this value will be same. Similarly, this value will be same. That is why just use only one Z inverse, just use one Z inverse, and from that Z inverse write like this and like this. So, that means draw in this manner. Take only one Z inverse. Finally, this is the diagram. Just instead of taking two Z inverse blocks, just take one delay element. Here one delay element, here one delay element, like this. Here the last term in x is x of n minus m. That means m delays are needed here. Here n delays are needed. So, they may not be equal. That is why here by assuming n is more than m, I have drawn this diagram. My assumption is n is more than m. So, if m is more than n, suppose if m is more, then this side will be more when compared to this one. More delays will be there on this side when compared to this one. This is the diagram by assuming where n is more, n is more. That is why this side has more Z inverse terms. So, this is called direct form to structure. This one is called direct form to structure. This structure is called direct form. This one is called direct form 1 and this one is called direct form 2. The major difference between this one and this one is the number of delays are reduced. The number of delays are reduced. The reason is we are using a common delay element. So, that is why the number of delay elements are reduced. Remaining are same as before. That is adders are same, multipliers are same, but delay elements will be reduced. So, if we follow this approach, the number of delay elements will be maximum of m comma n, maximum of m comma n. That is about the number of delay elements. Remaining are same, adders will be m plus n, adders will be m plus n, multipliers will be, adders will be m plus n, there is no change in adders and there is no change in multipliers. The only difference is in delay elements. The delay elements are, the number of delay elements are reduced if you follow this approach. And you can remember this diagram like this. In the middle write delay elements, and this side is y and this side is x. This side is y and this side is x. Like this we will write. This side is y, this side is x. We will see some more problems on direct form to structure. Suppose let us take IR filter, which is like this. That means y of n is, take these two to the right side, then y of n will be like this. Now if you draw the direct form to structure, it will be in this manner. In the middle write delay elements. If you observe x of n minus 2, y of n minus 2, that means at most 2 delay elements are needed. This side is always y, this side is x. So think like this is y side, this is multiplied with minus a1 and this is multiplied with minus a2 and here b0 will come. Think like this is, whenever you are drawing like this, think like this point is x, b0 into x, and x of n minus 1 into b1, x of n minus 2 into b2 and so on. Whenever you are drawing this part, think like this is y, y of n minus 1, y of n minus 2. If you are drawing this one, think like this point is x. Like that you have to draw. That is one simple technique. So here so whenever the input output relation is like this, this is the direct form to structure. Sometimes based on transfer function, we have to draw the direct form to structure. Suppose if you take this one, then h of z will be in this manner. H of z will be b0 plus b1 z inverse plus b2 z power minus 2 by 1 plus a1 z inverse plus a2 z power minus 2. If you observe carefully, this is numerator side, this is denominator side, this is denominator side, this one, and this one is numerator side. If you observe carefully, here these numbers are coming as it is, b0, b1, b2, whereas here nothing will be there, nothing is there means 1, always the signal flow is like this, signal is going like this, here always it is 1, we did not write any number means that value is 1, so here actually it is 1. If you observe, these numbers are coming in with the amplitude reversal, that means here a1 is there but minus a1, here minus a2, that is these numbers will come with opposite sign and these numbers will come as it is. Like this we can draw direct form to structure. We will see one more example. Suppose if h of z is like this, Now the corresponding direct form to structure is in this manner. Here at most z power minus 3 is there, that is why 3 delay elements are needed. So this side is a numerator, so here B0 will come, here B1 will come, B1 is 20, here B2 will come, B2 is 30. That is about right side. Always this number is 1, always the signal flow is in this manner, and these numbers will come with opposite sign. So here 40 is there, that is why here minus 40. This number will be minus 50, this will be minus 60. So finally, like this we can draw based on h of z. Always write these numbers with opposite sign. These numbers with the same sign. Always this number will be 1. The direction is like this number will be 1. We will see one more example. Suppose now I will based on a diagram, I have to write I want to write h of z. Now the reverse. Sometime back what I told you that for a given h of z, how to write the structure. Now I am giving the structure, now I will explain the procedure to write h of z. Now I will write the equivalent h of z for this one. Always this side is numerator, so B0 plus this is B1, B1 z inverse, so 2 z inverse plus, think like this, just identify the term in this path, so 5 plus z inverse into 2, 2 z inverse plus here z power minus 2 into minus 3, so minus 3 z power minus 2, and from here to here z power minus 3 into minus 4, so minus 4 into z power minus 3. That is about numerator. Think like this, write the terms in the path. So this is one path, so this path contains 5, and now this is another path to this in this direction, z inverse into 2, 2 z inverse, z power minus 2 into minus 3, z power minus 3 into minus 4. That is about numerator. The denominator is always 1, always the first term is 1. Then always now see in this direction, so here z inverse into 10 z inverse, write these terms with opposite sign, so z inverse into 10, so minus 10 z inverse, and here z power minus 2 into minus 20, minus 20 z power minus 2, opposite sign is plus 20 z power minus 2. So always the here the sign of the denominator numbers is opposite of these signs, opposite of these signs, opposite sign, right, opposite sign for these numbers, that is minus 10 plus 20. Here same sign, these numbers will come with the same sign. This part gives denominator, this part will give numerator. Like this we can write h of z very easily based on direct form to structure. Suppose sometimes what happens is, see this direct form to structure, sometimes this may be absent, suppose this part may be absent. Suppose here y of n is given like this, then the procedure is same, always this part is a numerator and this part is denominator. Now here the first always identify the terms from here to output, identify the terms in the path from this point to this point. If you observe, first term is b1 z inverse, so this one, the next term is b2 z power minus 2, so that is this b naught is absent, so don't write it, don't write it. See here there are only two paths from here to output, two paths from here to output, one path is b1 z inverse, another is b2 z power minus 2, and write this one. Suppose this is also absent, then this is also absent, then now only one term b2 into z power minus 2, b2 into z power minus 2, you will get only one term like this. Suppose here it is like this, then some b naught into, now here only one path is there, on that path the b naught is there, b naught always this side is numerator, this side is denominator, so b naught, just b naught, just b naught by this one, always these numbers will come with opposite sign. So actually minus a1, so a1 z inverse, here minus sign is there, but opposite sign means a2 z power minus 2. So like this you can write h of z very easily based on direct form to structure. Now I will explain one problem on IR filter. So here one direct form to structure is given, it is asking unit step response. Unit step response meaning is the response due to unit step input, the input is unit step and he is asking output. Unit step response meaning is input is unit step, input is unit step. Here one relation is there between step response and impulse response. Always the impulse response is equal to first difference of step response. Here my assumption is C is a step response. Here my assumption is like this, h of n is impulse response, C of n is step response. Always impulse response is differentiation of, impulse response is first difference of step response. It is similar to continuous time relation. In continuous time it is like this, suppose if h of t is impulse response, c of t is step response, impulse response is equal to differentiation of step response. Impulse response is always equal to differentiation of step response. We can remember this one like this, always impulse is differentiation of step, impulse is a differentiation of step, that is one standard relation, impulse is differentiation of step, So, impulse response is differentiation of step response. Like this you can remember very easily. Impulse is differentiation of step. So, impulse response is differentiation of step response. Differentiation is equivalent to first difference in discrete time, first difference, in continuous time differentiation. First difference meaning is nth value minus n minus 1th value. So, first difference means h of n will be equal to, now instead of differentiation write first difference. First difference means nth value minus n minus 1th value. So, like this impulse response and step response are related. Always think with respect to jet transform, it is better. We can solve the problems very easily in frequency domain. So, since the question is about C of n, C of n meaning is step response. Always the approach is first to find C of z and take inverse jet transform of C of z, that will be C of n. That is a simple approach. First find C of z and inverse it, you will get C of n. So, if you apply jet transform, it will be like this. Here I need C of z. So, C of z will be equal to 1 by 1 minus z inverse into C of z, sorry, h of z. We are finding C. So, take this to the other side. So, h of z into 1 by 1 minus z inverse, and from this we can write h of z very easily. We can write h of z very easily for this one. So, this side is numerator, this is denominator. So, the numerator is like this, the h of z for this one is see, one path is in this manner. So, 1 into z inverse, and another path is like this, z power minus 2 into minus 1. So, minus z power minus 2 by, always denominator starts with 1, first term is always 1, and this path is 5 by 6 z inverse, right, always opposite sign, that is why minus 5 by 6 z inverse, and this path is minus 1 by 6 z power minus 2, always write opposite sign. So, plus 1 by 6 z power minus 2. So, that is about h of z. This is h of z. Now, substitute that one here. So, 1 by 1 minus z inverse into z inverse minus z power minus 2 by if you observe carefully, from the numerator you can take z power minus 1 outside, and for this one the factors are 1 minus half z inverse and 1 minus 1 by 3 z inverse. These are the factors of this term, and here 1 minus z inverse is cancelled, then is z inverse by 1 minus half z inverse into 1 minus 1 by 3 z inverse. Now, partial fractionate. So, the partial fractioning is like this. This is the finally this is the partial fractioning of this one. So that is about C of z. This is C of z. Now C of n is 6 into the inverse of this one is half power n into u of n minus 1 by 3 power n into u of n. Like this you can find. Here he did not mention about the type of the system, whether it is causal or non-causal. Whenever nothing is mentioned, always think it as a causal signal. That is why I wrote like this, u of n. U of n terms means causal. Sometimes he will clearly says that it is a causal system, non-causal system, then accordingly inverse this Z transform. If nothing is mentioned, always think it as a causal system, Now I will discuss about the procedure to find whether it is a low pass, high pass, band stop. One simple technique is there for IR filter. Based on poles we can tell, based on pole location we can tell the type of the filter. Always the distal frequency least value is 0, 0 is the least distal frequency and pi is the highest distal frequency. 0 is least distal frequency, pi is highest distal frequency. So if poles are around 0 degrees, if you observe, take a jet plane, this is one jet plane and in a jet plane this line is 0 degrees line, this one is 90 degrees, this is 180, this is 270. If poles are around 0 degrees, 0 degrees line, then it is a low pass filter. This is 0 degrees line. If poles are around 0 degrees line, then it is a low pass filter. Let us take one example. Suppose we have a pole on the real axis around here, it is 0.9. Only one pole is there, the pole is around here. So it is a low pass filter. If poles are around 0 degrees line, then it is a low pass filter. So the corresponding H of Z is like this. Pole is 0.9 means 1 by 1 minus 0.9 Z inverse. One minus 0.9 Z inverse means the pole will be 0.9. That is about the low pass filter. Next I will discuss about high pass filter. Take a jet plane and this one is unit circle, and we know that this is 0 degrees line, this one is 90 degrees, this one is 180 degrees. And highest distal frequency is pi, pi means 180 degrees. If poles are around pi, poles are around phase angle pi, then it is a high pass filter. So if poles are here, it is high pass filter. So one simple example is, we have a pole here at minus 0.9, then it is a high pass filter. So the corresponding H of Z will be 1 by 1 plus 0.9 Z inverse. So here 0 will be there, that 0 will be at origin. If you rearrange this one, it will be like this, Z by Z minus 0.9. So one 0 will be there, that is at origin. In this case also it is nothing but z by z plus 0.9. So, 1 0 will be there at origin. Only poles will decide the type of the filter, that is why I am talking about only poles. Suppose take a band pass filter. Band pass filter poles will be around 90 degrees, and minus 90 degrees. We know that this line is either 270 or minus 90. So, if poles are around 90 degrees or minus 90 degrees, it is a band pass filter. And last one is a band stop filter. BSF means band stop filter. We know that band stop filter is nothing but a combination of low pass filter plus high pass filter. Whenever you connect one low pass filter and high pass filter in parallel means plus, then that will be a band stop filter. So, band stop filter is always low pass filter plus high pass filter. So, here low pass filter means poles will be around 0 degrees, then it is a low pass filter. If poles are around 180 degrees, that is a high pass filter. If poles are like this, then it is a band stop filter, low pass filter plus high pass filter. Like this, based on poles of a IR filter, we can tell the type of the filter.